If c is greater than a half, how many lines to the point 0, c are normal lines to the parabola y equals x squared? What if c is less than or equal to a half? Okay, so some point 0, c. Let me just kind of randomly put a point here and call that 0, c. And we know that c is greater than a half, and we want to know how many normal lines there are to this. Okay, so I'm going to kind of sketch this in. Now a normal line is perpendicular to a tangent line. So a normal line is going to come in perpendicular to a tangent. So I'm just going to kind of sketch a tangent line right here. Okay, and let's go ahead and draw this normal line in. And these are just for visual. You don't have to actually graph this, but I want to give you a visual of what's going on here. So, all right. So the function is y equals x squared. And this is the tangent line to the function at some point. Okay, let me label this point. This point, let's start with just x comma y. Every point is x comma y, correct? But this point is also on this curve. So since y equals x squared, I can make it more specifically x comma x squared. I can replace the y with, substitute the y with an x squared there. Okay, so this point is x comma x squared. Well, every point on this parabola is x comma x squared. That's variable. I want this specific point. Now this may seem like a technicality, but it's really important. I'm going to label this point a comma a squared. And the reason why is variable everywhere. This is a single point right here. We're talking about a single point of tangency. Okay, so it's really important to get the difference between all points and a single point. All points, variable, single point, constant. Okay, so now what we know about a normal line is it's perpendicular to a tangent line. So let's start by finding the slope of this normal line right here. And I have 2 points. Okay, so I can use algebra. Let's find the slope of this line using delta y over delta x. The change in y's would be a squared minus c, and the change in x's would be a minus 0. So we have the slope of this normal line between these 2 points right here. We can also find the slope of this tangent line because we can find the derivative quite easily. The derivative of this, dy dx, is 2x. It's a function waiting for an input, and my input value right there is a. So the slope is 2a of the tangent line. Well, we know that they're perpendicular. Okay? And so a perpendicular has a negative reciprocal relationship. So the slope of this normal line is also negative 1 over 2a. I flipped it upside down and changed its sign, negative reciprocal. So I found the slope of this normal line 2 different ways. I found it by finding 2 points and using algebra, and I found it by finding the slope of this tangent line by using calculus and inputting a. Okay, that's the slope of the tangent line, and they have a perpendicular relationship, so I flipped it upside down and changed its sign. This is the slope of this normal line 2 different ways, and they should be equal to each other. Okay, so I'm going to solve for a now. Let's cross product. This would be 2a cubed minus 2ac equals negative a. Okay? So I just distributed cross product. I'm going to get all the a's to one side. So I have 2a cubed minus 2ac plus a equals 0. Okay, I see a common A. All right, I'm going to common 2A. And you may be saying, wait, there's no 2 on there. It's okay as long as I divide this by 2. Watch what I do. I factor out a common. You could go either A or 2A. I'm going to factor out a common 2A. That would leave me with A squared minus C plus I equals 0. I just wanted to have this leading coefficient 1. That's why I did that. Okay, so now I have a product equal to 0. So I can separate the product. 2A equals 0 and A squared minus C plus a half equals 0. And remember what I'm trying to do. I'm trying to solve for A. What is this A? Okay, so I divide by 2 and I get A equals 0. And then I'm going to move these to the other side to solve for A. So A squared equals C minus a half. And then I'm going to square root. A equals positive and negative the square root of C minus a half. Okay, so this implies there are 3 normal lines here and 2 solutions here. Okay, A equals 0. So if it's right here at 0, then it makes sense that this normal line would come right in perpendicular to this tangent line right here. That makes sense. Here, there's one on the positive side, but there's one on the negative side too. That makes sense. And let's go back to here. This is for C is greater than a half. Well, why? Well, because if it is greater than a half, then I have a positive argument of a square root, okay? But if C were less than or equal to a half, let's take a look at that for a second. Well, if it's equal to a half, we're at 0. Well, we already had that one. There's one solution. If it's less than a half, then I have a negative argument under a square root, which provides no real solutions. So if C is less than or equal to a half, we have one solution. If C is greater than a half, then we have 1, 2, 3 solutions.